So, table patterns. You should have this paper in front of you. Yes. All right. So up here, you do not have a red and black line, but I have a red and black line. Do we see that? Everyone sees the red and black. So looking at the red and black line here, we're going to decide which one of these functions is the quadratic and which one is the exponential. Because depending on the view of your window, at times it can be hard to determine which is which. So what do y'all think? Which is which? Is the red one the quadratic or is the red one the exponential?
Exponential is the red one, right?
And why do you say that? Why?
That's say so.
Okay. All right. So by show of hands, how many of you think the red one is the exponential? So the red is right here. How many of you think this is the red one?
How many?
It's just a casual conversation. We got one brave person, 2, 3, 4. Anyone else think the red? 5, 6. Somebody else? You 6 are geniuses. It is the red one. Okay. The red one is y equals 3 to the x. Okay. Okay, I'm glad that you were honest about guessing. But the reason why is that as you look at the growth of it, it is not a very constant linear situation, right? It kind of happens really fast. Do we see that? Just kind of how the shape of it happens. So therefore, by default, that means that this is our y equals 3x squared. Well, the pen is not black, it's purple. But
No, I mean the line.
yeah, the line's supposed to be black. Okay, so without paying attention to that, what you should pay attention to is what is happening at x equals 0. So tell one method for determining which graph is which from the graph is analyze x equals 0. Okay. The reason why we analyze when x equals 0, does anyone remember the 0 power rule? Zero power. 0 power rule is that any number to the power of 0 equals 1. Ringing any bells? Any number to the power of 0 equals 1. So when you have an exponential function, it cannot equal 0. Does that make sense? At 0, it cannot be 0. So notice here, our 0 is at 0, 1. That's because 3 to the 0 power is 1. Okay, the quadratic can equal 0, which is why it's the black. But you're analyzing what's happening at the 0. That would be your number 1 hint. All right. So we're going to talk about patterns. Another way that you can determine whether a table is quadratic or exponential, if a function is exponential or quadratic, is by looking at the table. Okay. Clearly, I already have them labeled, right? So we already know that this is the quadratic. But we're going to talk about why. With the quadratic, you have what's called a common second difference. That means that when you have subtracted y2 minus y1 twice, you're going to start getting the same values. Does that make sense? So let's model that. So I'm going to find the difference from here to here, here to here, here to here, here to here. What is 3 minus 0? 3. What is 12 minus 3? What is 27 minus 12? 48 minus 27. 75 minus 18.
No.
You gotta,
23.
you gotta regroup. What's 15 minus 8? And then that's 6 minus 4. 27. Okay? So that's my first difference. If this had been the same, then we would have said that this is a linear. Are they the same? So it's not linear. Well, we know it's quadratic, but yes. That's because when you do the second difference, What do you get? What's 9 minus 3? What's 15 minus 9? What's 21 minus 15? What's 27 minus 21? So do you see how I have a common second difference? That's what makes me a quadratic. Got it?
Does that say minus y1?
It's y2 minus y1. That's a quadratic. So because it's a second common difference, this is what makes it quadratic. How's that? Easy enough? Okay. So quadratic is subtracting.
Since they're all sixes, that means it's a quadratic.
Yes.
But like if you did the other one, it wouldn't be all sixes.
Mhm. Okay, if this had all been the same, then it would have been linear because it only took you one difference. Does that make sense? But the first difference wasn't the same, so it's not linear. So it's not a degree of 1, it's a degree of 2, which is called a quadratic. Okay, all right, next, exponential. Exponentials are a little different. They have what's called a common ratio. Okay, so we have a common ratio. Common ratio means that instead of subtracting, we have our y2 divided by our y1. Because remember, quadratic exponential is repeated multiplication. How do you undo multiplication?
Plus 2.
You divide, right? So we're looking at how did I get here? So you have to have a common ratio. So that means that we are dividing. What is 3 divided by 1? What is 9 divided by 3? What is 27 divided by 3? 27 divided by 9. What are you talking about? What is 81 divided by 27? And what is 243 divided by 81? 3. So notice that they have a common ratio, which is why it is exponential. Because there's a common ratio, we are a exponential. How do we feel? Okay. Right? So here is the quadratic functions, and we're going to generate consecutive y values that have a common second difference, right? So we're going to complete each table. The goal here is to not have to do it a lot of times. We should be able to do this kind of like in our heads a little bit. So really quick, if I substitute in 0, we're going to work ourselves PEMDAS, right? Parentheses, exponents, multiply, add or subtract, right? So we're substituting 0 in. What is 0 plus 3? What is 3 squared? What is 9 times 2? 9 times 2, 18. And then plus 5 is, so our y value is 23. We survived. Y'all did it. Okay, let's do another one. Ready? We're going to substitute 1 in. 1 plus 3 is? 4 squared is? 16 times 2 is? 32 plus 5 is? 37. Whoop, whoop. We're doing it. All right, next.
Hold on. Hold on. X, we're going to switch it to whatever we get.
These are our x's, and these are the values we input. These are our input values. Right? Are we still good?
Yes.
So now we're on 2. We're substituting 2 in for x. What is 2 plus 3? 5 squared. 25 times 2. 50 plus 5. So my next value is? What happened? Okay. So now we can try to see if there's, what is the difference from 37 to 23? Difference. 14. What is the difference between 55 and 37? It's 18, right? 55 minus 37 is 18. With this theory, instead of me having to keep plugging in, if I find what the second common difference is, so this was my D1, now I'm finding my D2. What's the difference between here and here? 4, right? A positive 4. So that means from here to here, it also has to be plus 4. What is 18 plus 4? 22. So that means from here to here, I'm adding 22. What's 55 plus 22? 77. And then again, plus 4. What's 22 plus 4?
26.
Then from here to here, what's 77 plus 26? And then one more plus 4, and we get 30. What's 103 plus 30? Do you see how you did that without a calculator by recognizing the pattern? Oh my gosh, we're human calculators? That's crazy. All right, your challenge. I want you to try and do 4 and 5 with minimum calculator. Okay? 4 and 5, minimum calculator. Yes, minimum calculadora. I believe in you. So up here, on your number 4, your first 3 should have been 107, 98, and 83. So from here to here, 98 minus 107 was -9. From here to here, 83 minus 98 was -15. So my D2 would be -15 minus -9, which means that it would be -6. So now working backwards without having to substitute in. So that's -15 and -6 makes -21, which means that 83 minus 21 puts me at 62. Then on the next one, -21 minus 6 puts me at -27. 62 minus 27 puts me at what? 35. And then we're at -6 again. And then I'm going to subtract. That puts me at -33, which puts me at 2. Okay. Do we see that with the pattern, if we use the pattern, do we have to continually substitute values in?
Yes.
No. That's the purpose of the pattern. It's to find your shortcut. All right.
This is so specific.
All right. So we didn't get to it. We'll have to keep moving. We'll just keep moving on. All right. The conclusion here. Did anyone notice anything between our A, our C, and our D from our second difference? No one made a conclusion? Not squared, but what? No. This number, what's the relation between 2 and 4? Oh, what's the relation between -3 and -6? It's doubled. So the relationship here is that your common difference, your second difference, equals 2 times your A, your leading coefficient. Do we see that? So since I know that, I can start with my second difference, right? So what would be my second difference here?
8.
It would be 8, right? So I know that my second difference is going to be plus 8. And then I work my way from there. Okay? Well, you're 0. You still need your 0. 7 squared is 49. 49 times 4 plus 1 puts me at 197. Yep. Yes. Yes.